redeclare the things again and again inside the coding. So if we use a function, we can call it and simply do that operation. So next, the wrapping up of data and methods called encapsulation. It means in most modern languages like Java, they are wrap up some methods to classes, especially in paint classes and applet classes, thread classes. So they are specifically doing that class only, that task only. The encapsulation makes it possible for objects to be treated in black boxes. That means we can see only the objects but not the methods and characteristics inside that. So we declare some example in that. A typical Java example. So it create a class called circle demo. So there are two methods available for that: calculate circumference and calculate area. So in first stage, it creates a object from the circle class called C1, and if you want to get the area of the circle, you have to call the method called calculate circumference, calculate area, and if you want circumference of that circle, we have to call the calculate circumference. So the two operations are wrapped into those two methods. Next, early language Fortran in 77 version, it also allows to subroutines. So in here you can see that the sub function called FFT1R, called with two parameters, called to the operation. The goal is data encapsulation. Some description is also available in the bottom. So the subroutines also create the program very efficient. Fortran gives that a suitable example for that. So our next principle, the syntactic consistency. Let me briefly introduce it. In McLennan's book, it called that similar things should be look similar, different things should be look different. The idea is that when you are representing about some idea, the different things relevant to that idea should act in different ways. If there is a language which consists with huge various operations on similar looking syntax, the consistency cannot be maintained. The examples, two examples we have presented you. The first one is the Fortran's use of double asterisk notation. So it's for exponentiation, but if by some mistake, if you remove one asterisk, it operates on normal multiplication operation. So the clear idea we can get from the high level language C. In the first slide, in the first example, there is a pointer assignment. The pointer called first assigned to pointer called out. But in second stage, there's one asterisk from the left side is removed. So it says that the first variable multiplied by the out and assigned to the left side out variable. So similar looking two statements, but without one asterisk, it creates some different idea or different operations. So this is structured program principle. Simply says the visualization of the execution process. Most of the languages in nowadays created on basics and the principles. So what it should be is understandable. So the above principle is used to visualize the execution process. The concept